Hello guys, I hope you are doing fine. Have you ever think about 0 factorial or any number to the power 0 or 0 to the power 0? Can you prove the value of these or not? Let's see together. So let's start with 0 factorial. Can you imagine what is 0 factorial? Me, I cannot imagine. But with the mathematics, we need to calculate it. First, let's see the definition of factorial. X factorial is equal to x times x minus 1 times x minus 2, and it goes to times 2 and 1. So we need to actually follow the induction proof in mathematics. Let's start with 1 factorial. It's equal to 1, as we know all. Let's continue. 2 factorial it's 2. 0 factorial equals 6. Let's continue. 4 factorial 24. 5 factorial, yes, 120. And now I want to come back from 5 factorial to 1 factorial. If I want to come back from 5 factorial to 4 factorial, so the value of 120 is divided to 5. So 120 divided to 5 equals 24. 24 divided to 4 is equal to 6. 6 divided to 3, yes, 2. And 2 divided to 2 is 1. Can we continue? Yes. And 1 divided to 1 is equal to 1. So it's easy. 0 factorial is equal to 1. Let's calculate any number to the power 0. As we know, a to the power m equals a times a times a, and we have m times. Let's start with 2 to the power 1. We know that it's equal to 2. 2 to the power 2, 4. 2 cubed, yes, 8. 2 to the power 4, 16. 2 to the power 5, 32. And let's come back from the last expression. If we want to come back from 32 to 16, it should be divided to 2. Then from 2 to the power 4 to 2 to the power 3, we need to divide 16 to 2, so we have 8. And we can continue. 8 is divided by 2, we have 4. 4 divided by 2, we have 2. And the last one, yes, 2 divided to 2 is equal to 1. So it's interesting, yes? Let's see what's the value 0 to the power 0. To solve this, I want to start and see. We know that x to the power 0 is equal to 1. We know that 0 to the power m is equal to 0. So, what is the value of 0 to the power 0? It's 1, it's 0, or any number between 0 or 1. Let's see together. Let's start with 1 to the power 1. It's equal to 1, as we know. Let's decrease the value. 0.9 to the power 0.9. You can calculate with calculator if you want with me. It's equal to 0.9095. So it seems decreasing. Let's decrease and go to the next expression. 0.8 to the power 0.8. Yes, it's equal to 0.8365. And let's continue. 0.7 to the power 0.7. Yes, equals to 0.7790. Continue. 0.6 to the power 0.6 equals to 0.5360. As we can see, the trend is decreasing. But see the difference between 1 and 0.9. It's around 10% decreasing. And the other one, it's decreasing, but the difference between each two of them, yes, it's decline also. Let's see what will happen. So 0.5 to the power 0.5, it's 0.7071. Yes, the slope of decreasing is decreased. Yes, next one. 0.4 to the power 0.4 equals 0.6931. Yes, these two numbers 050, 070 and 069, they are very close together. So let's continue. 0.3 to the power 0.3 equals 0.6968. Wow, it's increasing and it's interesting. So what happened here? Let's continue to see the pattern and the trend. 0.2 to the power 0.2, it's equal to 0.7247. Wow, it's increasing as well. Let's continue. 0.1 to the power 0.1 equals to 0.7943. Let's decrease. For example, 0.01 to the power 0.01. Wow, it's incredibly increased. It's equal to 0.95. And if we continue, we see that 0.001 to the power 0.001 equals to 0.9931. Let's continue. The next number is 0.990. So if we continue this trend, and finally we will have 0 to the power 0 is equal to 1. And actually, if we have a function of x to the power x, so the limitation of this function when x approaching to 0 is equal to 1, as you can see in this curve. So if we start from the 1, it is decreasing until this point, and then increasing to the 1. So I hope you enjoyed this video, and if you like this video, please subscribe and like, and see you in the next episode.